This video covers the concept of work. Work is a scalar quantity, so it can be positive or negative, and it does not have a direction that is associated with the force acting on an object as it moves through some distance. So the equation for work done by a particular force is that force multiplied by the distance the object travels. And the unit for work is a Newton meter, which is commonly called a joule. It is important to note that when work is done on an object, it can be positive, negative, or zero. When both the displacement and the force are exerted in the same direction, the signs will be the same, and therefore the work will be positive. And if the force opposes the movement of the object, then the work done by that particular force will be negative. And if the force exerted on the object and the displacement are perpendicular, then the work done by that force will be zero. So let's do an example to work with this information further. A block is pulled by a rope with a tension of 20 newtons. There is a kinetic friction force of 5 newtons opposing the block's motion. If the block moves 5 meters, what is the work done by the tension force, the kinetic friction force, and the normal force? Alrighty, so the first step is to draw a free body diagram. So we have a normal force acting up, a weight force acting down, a tension force acting to the right, and a kinetic friction force acting to the left. We will first analyze the work done by the tension force. We know that the tension force is 20 newtons, and the displacement of the object was 5 meters. So when we place both of these values into the equation, we see that the work done by the tension force is 100 joules. And it makes sense that this is a positive value since the tension and the displacement of the object were pointing in the same direction. For the work done by kinetic friction, we know that the friction force points in the opposite direction of the displacement. So when we plug in our numbers, the force is going to be negative, and therefore the work is going to be negative 25 joules. And finally, we know that the weight and the normal force are perpendicular to the displacement. So we know that both the work done by the normal force and the weight force are going to be 0 joules. Finally, you could be asked to find the total work done on an object, and to do this, one would simply just add all of the work done by the individual forces. So, for this object, the total work done would be 75 joules. Or you could calculate it by multiplying the net force, which here is just simply tension minus weight, by the displacement, and we would once again get 75 joules.